Hi everyone, and welcome back to Astronomy Fun Facts. Today, we are going to talk about Obler's paradox, which is the idea that if the universe is infinitely large, which we think it is, why is the night sky dark? So if you imagine that the universe is infinitely large, that would mean that no matter what direction you look in the night sky, eventually, somewhere along your line of sight, there is going to be something, a star or a galaxy, that produces light. So that means that the night sky should just be uniformly bright all around us. This is not what we see. So how do we explain this? Well, the answer is twofold. So the first thing has to do with the fact that although our universe is infinitely large, it is not infinitely old. Our universe is 13.8 billion years old. Now, if you'll remember, light takes time to travel. It does not travel at an infinite speed. It travels at 3 times 10 to the 8 meters per second. This means that if you can imagine an object that is so far away from us that the light has been traveling for 13.8 billion years, but still hasn't gotten to us, we won't be able to see it. So this means that although our universe is infinite, the actual observable universe, the universe that we can see, is finite. It is limited to the objects whose light can get to us over the course of 13.8 billion years. The second thing that helps to explain Obler's paradox has to do with the fact that the universe is expanding. So since the beginning of our universe has slowly been expanding, meaning that space itself has slowly been stretched. Now, as this stretching happens, not only is matter moved, but light itself is actually changed. So that means that light that has been emitted from these very distant objects is slowly getting stretched into longer and longer wavelengths. Eventually, that light will stretch from wavelengths that we could see, that are visible, into wavelengths that our eye can't detect, like infrared and radio. This means that even if light has had enough time to reach us since the beginning of the universe, it is likely to have moved into wavelengths that aren't detectable by our eyes. So, when you combine the fact that our universe has a finite age, and so our observable universe is finite, and that light from the very early universe has been stretched into wavelengths we cannot see, this explains why our night sky is dark, why we only see a certain limited number of the total number of objects that are in the universe. Astronomy Fun Facts, Speed Round Edition. First up, did you know that a white dwarf is so dense it would be like fitting the entire mass of the sun into a sphere the size of our planet? And a neutron star is so dense, it's like fitting the entire mass of the sun into a sphere roughly the size of a city. The distance between the Earth and the Moon is so large that you could fit every single planet in our solar system in between us and the Moon. We think the Moon formed when an object roughly the size of Mars hit Earth as the planet was forming, resulting in a large collision with a bunch of fragments that eventually combined to form the Moon. And my final fun fact is that when you make TikToks about Star Wars, people will get very upset when you don't distinguish clearly between the world of science fiction and the world of real science. Hi everyone, and welcome back to Astronomy Fun Facts from an Astrophysics PhD student. Today, we are going to talk about dark energy. So what is dark energy? Well, we don't really know. All we can talk about is why we think it exists. Now, when we look at galaxies and galaxy clusters that are really far away from us, we notice that they're all moving away from us. This indicates that the universe is expanding. Everything in the universe is moving away from everything else. Now, when you think about it, this doesn't really make sense. In a universe dominated by gravity, we would expect things to be coming together, not moving apart. So this raises some options. Maybe the universe is expanding now, but eventually it's going to stop expanding and then contract. Maybe the universe is just going to keep expanding at its current rate. Or maybe the expansion of the universe is actually going to accelerate, and this last possibility is actually what we see. Instead of the universe expanding and then contracting, or expanding at a constant size, it seems like our universe is expanding and the rate of the expansion is accelerating. Now, what on earth could be causing this? And this is where dark energy comes in. Astronomers realize that in order for the universe to be expanding and accelerating in its expansion, there needs to be some other force, something out there that is causing this expansion to accelerate. We called it dark energy because we can't see it, it doesn't interact with anything in the way we know other things interact with things, and it's essentially a complete mystery. But it's a giant portion of our universe. Our universe is about 70% dark energy, and then 25% dark matter, and only 5% of the universe is normal matter that we interact with daily. So this is what dark energy is. It's some mysterious something that is causing the expansion of the universe to accelerate. There are researchers who devote their careers to figuring out what this could be. I am not one of them because the math is hard. Hi everyone, welcome back to Astronomy Fun Facts from an Astrophysics PhD student. Today we are going to answer the question, what is a nebula? Because it's one of those words that you've probably heard of in astronomy, but you may not actually know what it means. Now, the basic definition of a nebula is that they're a giant cloud of gas and dust in space, and they're some of the most beautiful objects in the universe. There's a lot of different types of nebula, but today we're going to talk about two broad categories: nebula that exists as stars are being formed, and nebulas that exist at the end of a star's life. In the first category, you have objects like this, the Eagle Nebula. Now, this thing is giant. It's over 70 light years across. And what's actually happening here is that we have these big regions of gas and dust, and as the gas and dust collapse, they form stars. And as those stars are birthed, they emit a lot of radiation that causes the gas to glow. And so you get these beautiful, colorful structures like this. The Orion Nebula is another one of these type of stellar nurseries, although this one is only 12 light years across. At the other end of the stellar life cycle, we have these, what we call planetary nebulas. And what these are is essentially the leftover remnants of a star. Now, these are still big. They can get up to about 1 light year across, but they're significantly smaller than the other types of nebulas because they're only glowing from the light emitted by one star. Now, what you have here is in the center of these regions is a small white object that we call a white dwarf, and that is the leftover core of a star roughly the size of the sun. As that star reaches the end of its life, the pressure becomes so great inside the star that it pushes away the outer atmospheres. So all of this glowing gas is the outer layers of the star that have been pushed away from the core and are now glowing from the light emitted by the white dwarf. You can also have nebula like this one, the Crab Nebula, which is actually what we call a supernova remnant. So it's what's left over after a star has exploded. Hi everyone, and welcome back to Astronomy Fun Facts from an Astrophysics PhD student. Today, we're going to talk about the Galilean satellites. So what are the Galilean satellites? They're just the 4 largest moons of Jupiter, and they're also some of my favorite objects in the solar system. Moving from the outside in, first up we have Callisto, which to be honest is my least favorite of the 4. Now Callisto is large, it's about the size of Mercury, and it's the 3rd largest moon in our solar system. It's made of rock and ice, and it's possible that it has an ocean underneath its surface. Next up, we have Ganymede, which is the largest moon in our solar system. It's larger than both Mercury and Pluto. It's also the most heavily cratered object in our solar system, which you can kind of tell looking at it. It is also the only moon that we know of that has its own magnetic field. Continuing to move in towards Jupiter, next up we have Europa, which is my favorite of the Galilean satellites. Europa is covered in a sheet of water ice that is 10 to 15 miles thick, and underneath that water ice, an ocean. This is one of the leading candidates for life in our solar system, and there are actually some missions coming up that will explicitly explore the potential for life on Europa. And finally, we have Io, which might be the ugliest thing in our solar system. Io is the closest moon to Jupiter, and it has a very elliptical orbit, meaning it goes from far away from Jupiter to very near to Jupiter. And as it does this, the change in the gravitational force it experiences actually expands and contracts the moon, raising and lowering the surface by as much as 100 meters. This expansion and contraction heats up the interior of Io, which causes it to have a lot of volcanic activity. It's one of the most volcanic objects in our solar system, and all of that volcanic activity is what makes it such an ugly color.